Hello everybody. Today we are going to discuss the real functions, real valued functions. Into that some of the popular functions and their domain and range, including their graph, arrow diagram. We are going to see greatest integer function. Okay, so this function is also a real valued function which is defined from R to R, and such that this function is generally represented in this form in close bracket, which means that this is the function which is giving all the outputs integer. That's why its name is also greatest integer function. Why greatest word is coming? Because it is taking the greatest integer with respect to that particular number which is entered into that from left side. That means if I have one number line on that, if any particular point you are choosing for greatest integer function, suppose 2.3. So with respect to this 2.3 point, from left side, what is the greatest integer on this number line? That is going to be 2. Okay, because 2.3 is situated between 2 and 3. So that means 2 is going to be the value of this greatest integer function of 2.3. Similarly, for example, if it is going to be considered, suppose minus 1.5. Okay, that means this number is situated somewhere between minus 2 and minus 1. That means minus 2 is here and minus 1 is here. So that means this number is going to be in between minus 2 and minus 1 at the middle, where we can find out the greatest integer of this particular number. Greatest integer function will give the value of minus 1.5 as minus 2. Why minus 2? Because minus 2 is the greatest integer before this particular number from left side. Okay, because right side every number is greater than this number, but from left side whatever is the greatest number from that point for which we are choosing the greatest integer function, so we can find out with respect to the number line easily if there is any confusion. Similarly, one more example, if I say that if suppose it is 0.99, so you know that 0.99 is a number situated between somewhere between 0 and 1. Suppose that it is 0 and it is 1. So 1 is very close to 0.999, but it is not the 1. Means if we look for the greatest integer from left side with respect to this 0.99, so that is going to be 0 only, because until and unless it is not reached at that integer, left side integer will be taken the greatest integer function of value of that particular integer. And if any integer is inside it, in that, suppose that it is 5, so it is going to be taken as it is. There is no change into that if it is any integer value, because left side or right side, whatever you take on that integer, the integer itself is going to be output. But as soon as any number is shifted little extra left side, for example, if it is 4.99, which is very close to 5, but the greatest integer function value of this particular point 4.99 is not going to be 5, it is going to be 4, because every number which is situated between 4 to 4.99999, even very close to 5 also, the greatest integer function value is going to be 4, because the nature of the function is such that how it is defined. So let's see how it is defined. So greatest integer function x is going to be defined as, here it gives you 0 whenever the x is situated between 0 to 0.9999, or you can say it is less than 1, means not equal to 1 but less than 1, but greater or equal to 0, it will give you always 0. And if a number is situated between 1 to 2, it can be equal to 1 but less than 2, not equal to 2. So for all such values of x, the output will be 1. Similarly, when x is situated between 2 and 3, it can be equal to 2 but it is not equal to 3. Means all the values situated between 2 and 3, for such x, the output will be 2 only. Similarly, it goes on, and this way we can also proceed on the negative side also. If a number is situated between -1 to 0, where number is less than 0 but it is equal or greater than -1, so all such number values of x is going to give you output as -1. And if a number is situated between -1 and -2, so where it is equal to -2 or greater than -2 but less than -1, so for all such values of x, the greatest integer function values will be -2. So here this way it can go up to negative side also. In this way, following the same pattern, so we can see that between the integers various values of x are possible, but their output is always integer. That's why we say that this greatest integer function range is always integer value. Okay, and but domain can be any of the x. So that's why if we define the domain and range for this function f, which is greatest integer function, so domain of this function will be all the real number, but range of this function f is going to be only the integer value. Z is the symbol for integer set, or you also use one of the symbol for set of integer, that is capital I. So range of f will be capital Z or capital I, but domain of this function will be capital R. So I hope this greatest integer function, by definition it is clear. Now we are going to see the graph and its arrow diagram. Okay, let's see that. First, the arrow diagram here for the greatest integer functions. So if we are taking some random elements into the domain, for example, -3 by 2, -1, 0, 2 by 3, or 5 by 4. So you see that here I have taken all variety of the numbers, mean negative, positive, fractions, integer, all. Okay, so if we going to take these elements as input of the greatest integer function, if this f is the greatest integer function, so what output it will give us? So here -1 will be projected as it is, because we have seen that there will be no change in the integer value. 0 will be also going to be projected as it is, 0 only. But 2 by 3, which is the number situated between 0 and 1, you know that 2 by 3 is approximately 0.66, which is a number between 0 and 1. So for such number which is situated between 0 and 1, for that greatest integer function output will be 0 only, because you know that any number between 0 and 1 will give you the output 0 only. Okay, similarly here 5 by 4, it is the number more than 1 situated between 1 and 2. So for such function, the greatest integer function value will be 1, because the number is situated between 1 and 2. So left side integer, the greatest integer, which is 1, so that will be output for this. Similarly here -3 by 2, which is -1.5, which is situated between -1 and -2. So for this, the left side integer is -2. So that means for this, the greatest integer function value will be -2. So you can see that for variety of the numbers, whatever we are choosing, we are getting all the output as integer only. That means whatever output will be here, those outputs are going to be integer. So that means the range which you are going to get for this function, that is going to be capital Z, or you can say set of integers. And you know that set of integer is also subset of real number. So that's why this circle, which is representing the range, that is inside this codomain capital R. So here capital R is the codomain for this function, but here capital Z is representing the range for this function. So here domain is also capital R. That means your set of real numbers, but your range is set of integers. Okay, so now we are going to see the graph of this function. So let's see the graph. Okay, so here the Cartesian plane, I have plotted the x and y axis. And now in this we are going to see the projection of the greatest integer function. So we have seen that greatest integer function gives you all the values which are situated between 0 and 1. Their output will be 0 only. So all the values which are situated between 0 and 1, suppose it is 0, it is 1, it is your 2, it is your 3, it is your 4, it is 5. Similarly this side -1, -2, -3, -4. So all the values which are between 0 and 1, for them the output is 0 only. Okay. But all the values which are between 1 and 2, including 1 also, for them the output is 1. So that means between 1 and 2 the graph will be corresponding to this line 1. Okay. So on y-axis also I can indicate 1, 2, 3, 4. Downside also similarly -1, -2, -3, -4. So all the values which are giving the output between 1 and 2 as +1. So in that 1 is also included. That's why here this point will be going to be circled at the corner. That means 1 is also included. And here will be arrow only, because this at 2 it is not included, or you can make the hole. Okay, or you can make the small hole in which this will be hollow inside and this will be darkened. And between 2 and 3, because all the values are output as 2 here, so it will be here projected corresponding to this 2, and here it will be darkened, that is showing that corresponding to 2 is also included, but 3 is not included into that. That's why here you can make a hollow circle. Okay. Similarly between 3 and 4 all the values will be projected corresponding to 3. So between 3 and 4 all the values are projected here, and they will be here representing that 3 is also included. So here it will be circled, and here 4 is not into that, so here you have to make a open circle. So this way we have projected as for the positive numbers intervals. Similarly on negative side also we can do the same projection. So any number which is between 0 and 1, so they will be representing the 0 to 1 here, in which 0 is included, but at 1 you have to make a circle. And here between -1 to 0 any number will be correspondingly plotted with respect to this number -1, and here this -1 is included, so it will be darkened, and here it will be open circle. Okay. And with respect to this interval -2 to 1, -2 to -1, in which any of the number is coming as the input of the greatest integer function, so their output graph will be corresponding to -2, which will be here, where this -2 is included and this -1 is not included into that. Okay, so this way the representation are there. We can proceed on the negative side also in this way, and it also goes to the positive side as it is. So you are getting a graph which is in form of staircase. Okay, just like staircases, we are having the graph step by step between the different intervals. It is giving the y values as integers only. That's why none of the values which are non-integer are part of the graph. So between the integers there is a emptiness, there is a hollowness between the integer corresponding to the y. Suppose any value of y you are choosing which is non-integer, for example 2.5 if you are choosing, so corresponding to that there is no graph available. That means there is no any output as non-integer into this arrow diagram. Also you have seen that there is no output as non-integer. If you are choosing any non-integer from this real number set from codomain, for example suppose you are taking 1 by 2, so 1 by 2 has no pre-image into this domain. That's why 1 by 2 is not the part of range. This way also you can check that any number is a part of range or not, because if it is not associated with any domain image, so that means it is not part of the range. So it is present in codomain, but it is not part of the range. So many real numbers are here which are real number but they are not integers. So that's why they are not part of range of greatest integer.